Hi, folks. We're just letting people join, and then we'll get started in a minute or two.
Seeing a question about recording. We will be recording and it should be available to be viewed later. So thanks for asking.
Thanks, folks, for joining. We'll be getting started in just a minute. And I think Blake is going to do housekeeping for us at the beginning of this in terms of Q&A.
All right, I'm seeing that we are at 3 p.m. and we do have a lot to cover. So we will get started right away. So hello, everyone, and good afternoon. Thanks for joining us today. We have a lot to cover, like I just said, but if you do have questions, feel free to put them in the chat or the Q&A. And any comments also feel free to share, and we'll try to be sure to get to them at the end of the presentations. We'll also be trying to share some additional resources in the chat as we move along today. So just keep an eye out on the chat. So with that, I'm Leica Knefman. I'm a senior specialist on the Ag program at National Wildlife Federation. And joining me today are Kim Pitcher with Prairie Rivers Network, who also happen to be the Illinois affiliate of the National Wildlife Federation. Also, we'll have Emily Maeve with the Xerxes Society for Invertebrate Conservation, Rob Fox, who's a grower in Iowa, but also with Pesticide Action Network, and we'll have Max Sano from Beyond Pesticides. And a number of our partners and friends from our informal herbicide working group are on the call today as well. So we'd like to be talking today to you about herbicides, mainly because they are one of the most widely used pesticides across many landscapes globally, but more specifically talking about the damage to wild plants and the wildlife that depend on them from drift-prone herbicides, since there are significant threats that have not been given adequate attention. So hopefully my slides are advancing. Okay. And so with that, let's just start with some herbicide history. This will be a review for many of you, but we did think it would be important to give context for what we're talking about today. So before World War II, farmers mainly used a combination of manual strategies to control weeds in crop fields that included tillage, crop rotation, and mechanical weeding. There were some inorganic salts and acids used for weed control, like copper sulfate, but they weren't very effective. And then in the 1940s, the discovery of and commercial release of synthetic herbicides, the chemical hoe, if you will, dramatically changed the face of agricultural weed management. The first herbicide released is one commercially is one we're still familiar with today, 2,4-D, as you can see in that ad. And then from the 1950s to the 1980s, on average, new herbicides and new modes of action were discovered and released every other year. Hundreds of new herbicides, really. And a mode of action is the overall manner in which an herbicide would impact or affect a plant at the tissue or cellular level. But the pace really slowed down significantly after the 1980s. And since then, no new major modes of action or basically no novel ways of killing plants have been released. So herbicide resistant crops then were introduced in the late 90s or in the 90s. And this really cemented herbicides, primarily glyphosate, Roundup, which many of you are familiar with, as the main form of weed management across millions of acres of U.S. row crops. Now, over 90% of corn, cotton, soybean acres have been planted in herbicide-resistant varieties and for the last 2 decades. So, like other pesticides, herbicides that are applied to and around crop fields do not stay put, and sometimes a large percentage or a majority of the chemical applied to a field ends up elsewhere in the environment. And this causes widespread contamination of soil, water, and non-target plants, and can have a variety of downstream impacts on biodiversity, something which we all care about. So with that, this near universal adoption of glyphosate-resistant crops led to the development of substantial weed resistance to glyphosate. Glyphosate-resistant weed species have emerged in at least 120 million row crop acres, particularly in the U.S. Midwest and Mid-South. And, thinking back to that history where no new technologies since the 80s meant, and given the cost and time required to develop these, companies decided to turn back to older herbicides, such as 2,4-D and dicamba, as replacements for or in addition to glyphosate resistance in crops. So they developed crops resistant to these chemicals and new formulations of dicamba and 2,4-D meant for use in these resistant crops. So dicamba and 2,4-D have historically had trouble and known problems staying put. Researchers predicted that if they were used later in the season when temperatures are higher, which is when dicamba particularly would be used for post-emergent weed control in those dicamba-resistant crops, that movement and plant injury were from vapor drift is most likely. Despite this, 3 new herbicide formulations were approved by the EPA, and this is again specific to dicamba, and they were marketed as solving the issue of volatility and were and hit the market in time for the 2017 growing season. And there are many other herbicides being applied. The next slide sort of shows the trends and in the use of the 5 most popular herbicides. And the graph illustrates the fact that the use of these popular herbicides is increasing in general because of widespread resistance and lack of diversity in weed management. We are essentially locked into an expanding reliance on herbicides. We used to just use them early in the season and then do tillage and cultivation, but now we use them throughout. So if you look at the trends, the increase in the use is in the last decade for 4 of these herbicides, but atrazine has been widely used in corn throughout. So with this increase in use has come the increase in drift-related injury to off-target plants and trees. So just briefly, what is drift? Hopefully I can get this to work, but and you can see that, but in herbicides can move through the environment in numerous ways. The video shows that what happens during particle drift, droplets of the herbicide are carried away by wind from their intended target during application itself. They then land on non-target areas, causing injury. And then moving on to vapor drift. Volatilization is when the herbicide vaporizes or evaporates essentially off of soil and plant surfaces after application. The vaporized herbicide can then move along long distances in the atmosphere and land on non-target areas even miles away and cause injury. This can occur for several days after application, up to a week even. So this has been a huge problem and something many of us will continue to talk about as we move through this presentation today. So a number of our groups actually came together back in 4 years ago now, 2020, to talk a bit more focused on the impacts of dicamba and drift from dicamba and the impacts to wildlife and the plants and trees they depend on. You can find that entire report at the link in the slide here, and then Max can put it in the chat as well. And then before I hand it over to Kim, NWF does have some other gardening resources that hopefully many of you have seen already, but Max will put those links in the chat. Thanks. And with that, I want to pass it over to Kim, who will talk more on how to recognize drift injury and some of their monitoring data.
Thanks, Leica. Hello, everybody. I'm Kim Pitcher with Prairie Rivers Network. I'm the Director of Ecological Health. And just a little note here before I get started, I believe our chat is not working, so we're going to do a follow-up email with all the attendees and send all these resources that we mentioned to you in a follow-up email. Okay, so as Leica mentioned, we use herbicides and we use them a lot. We use them in weed control practices and lawns and turf care, management of rights-of-way, invasive species control, and of course, management of weeds and agricultural systems. And in general, we use a lot of pesticides. And when I say pesticides, I mean herbicides, insecticides, fungicides, rodenticides. In fact, the US uses approximately 1 billion pounds a year of conventional pesticides. So that's a lot of potential pollutants that we're putting out into our environment. Next slide. As Leica mentioned, in recent years, we've had increased reports of off-target injury to cultivated and wild plants. And that includes row crops like these soybeans here, which are clearly curled and cupped on the lower left. Also, we have specialty crops. This tomato plant here in the center is distorted, it's twisted, it's curled. And on the right, we have a photo of a sycamore leaf, very bowl-shaped, extremely cupped, classic symptom of a growth regulator herbicide exposure. Next slide. So before we talk more about symptoms, let's talk about what influences the severity of these symptoms in plants. First of all, it's the rate of exposure. How much herbicide was drifted or what's the plant exposed to? Also, the herbicide in question. Like I mentioned, there are different modes of action. They impact plants in different ways. Additionally, different species have different sensitivities to particular herbicides. And just like humans, individual plant health is different. If I am stressed, my immune system is compromised, I get exposed to a cold, I might get very sick. Whereas if you are just, not stressed and get exposed to the same virus, you might only have a case of the sniffles. So there is a degree of variability there in relation to actual individual plant health. Also, the growth stage of the plant is extremely important. particularly at bud swell and leaf emergence, we're noticing that trees are very sensitive to growth regulator herbicide exposure, same with flowering onset. Next slide. So when we talk about symptoms, I always like to show a couple healthy leaves in relation to injured leaves at the outset. And red buds are a great example. They're exquisitely sensitive to growth regulator herbicides like 2,4-D and dicamba. And on the left, we have a beautiful, smooth, flat, heart-shaped red bud leaf. And on the right, we have injured leaves. And this is the classic symptom of curling and cupping. You'll notice that the tips of these leaves are also pointed a little bit more than the healthy leaf. And they can cup up or they can cup downward, and sometimes even on the same tree. Below that, we have sugar maple. On the right, the injured leaves are curling, cupping. They're also yellow, and that's what we call chlorosis. Next slide. Grapes, whether they're a cultivar and used for some kind of food or added value product, or wild grapes, seem to be particularly sensitive to growth regulator herbicides. And here we see on the right an injured grape leaf. It's clearly stunted, its veins are yellowing, and its margins or the edges of the leaf are very irregular. Oaks are a species of concern, or are species of concern. This post oak down here on the lower right is severely injured. It has very curled, cupped, stunted leaves. It's almost like cobra-headed in its shape, and that is very typical of injury in this species. Next. So the next several slides are just, I'm going to go through them quickly, showing you some more examples of injury. This is sugar maple, and not quite as severe as the first sugar maple that I showed you, but these are drooping. There's a symptom called epinasty where the leaf droops or twists at the petiole, and these leaves are showing drooping or epinasty as well. They're also curling, cupping, and they have some yellowing. Next slide. White oak. One of the important things that we do when we go out and we monitor at Prairie Rivers is we look up in the canopy as well. Oftentimes you'll need binoculars for this or a nice camera lens, but it's really important to look up. And even from a distance, you can tell that this white oak has injury, and the leaves are very curled and cupped. The surface area of these leaves is reduced, and that's going to impact its ability to photosynthesize and make food. Next slide. Here's an example of that sycamore again, classic 2,4-D dicamba symptom, severe curling and cupping. Next slide. It's not just trees. It's also, of course, there's plants in our gardens and backyards, but prairie plants. This is a compass plant, and it's normally a very broad, beautiful plant with deeply notched leaves. And these leaves are curled, twisted, and clearly deformed. And here we have another silphium species, and this is rosinweed. And rosinweed typically, when it's exposed, the leaves twist almost like a spiral staircase. And one of the things that we want to notice about herbaceous plants or these flowering plants versus woody plants is that herbaceous plants can tend to grow out of an injury somewhat, if not just mostly throughout the growing season, especially those perennial herbaceous plants, because they continue to grow through the growing season, whereas a leaf on a tree isn't in that continual growth stage. And the symptoms on trees will be visible throughout the entire growing season, even up to leaf fall. Next slide. So in our monitoring, we have monitored symptoms of herbicide injury in 99 species of trees, 48 species of shrubs and vines, and 115 species of herbaceous plants. And that is from 737 monitoring visits. And hats off to my partner in this work, Martin Kemper, retired biologist with our Department of Natural Resources. He is a tremendous ecologist and has done a lot of this monitoring himself. Next slide. And so when we go to sites, we typically look at the ground layer, the understory, and the canopy. And we're looking at multiple different species and plant types to see if they're showing similar symptoms of injury. And one of the sites that we visited for multiple years in a row is the pasture that our beautiful state champion post oak lives in. It's Washington County, Illinois. This is a magnificent tree. It is in a large pasture with lots of other oaks and a lot of other species of trees and plants. Next slide. These are the pictures of the leaves from 2017 to 2023. And every year, this tree gets injured by herbicide drift. These leaves are stunted, they're twisting, they're not oriented to the sun the way that they should be. They're smaller than they should be. And important also to note is these leaves, when you touch them, are very thick. They are coarse and they don't feel like a normal leaf feels. Next slide. In addition to monitoring this tree, we've also took multiple tissue samples over the years. We typically take them about every 3 weeks to 4 weeks. And we've had 17 bags of leaves analyzed for residues of herbicides. 15 of those samples came back with residues of 2,4-D, 7 of dicamba, 3 of atrazine and metolachlor, and then we also detected glyphosate and glufosinate. And after looking at the parts per billion of those residues in the samples that came back in the analysis, and looking at the timing of when we would see new herbicides show up in sequential tests, we deducted that, excuse me, we concluded that this tree has experienced approximately 15 independent exposures over the past several years. So we're not only getting, injuries or drift symptoms showing up on these plants year after year, but it's happening multiple times within each growing season. And that really causes a lot of stress on these plants. Next slide. This is one of the neighbors to the state champion post oak. It's actually in the background there on the left. This is another oak. This tree has since died. This picture is a couple years old. And you can see that when this picture was taken, this tree is stressed. It is doing something called epicormic branching. It is putting its leaves out on its trunk and all over its main branches. And that's a last-ditch effort, essentially, to produce leaves and to make food. And there's also some branch dieback on that photo. So in 6 years of monitoring, we have been looking at both urban and rural locations. And so it's important to realize that this isn't only coming from agricultural lands, it's also occurring from, urban and, community-based use of these herbicides. We're seeing changes, though, that can impact ecosystems. We're seeing decline in oak health, we're seeing increased rates of tree death, and we're seeing changes in tree canopies. Next slide. And, it's not just in Illinois, and it's not just PRN. Even in Illinois, we have the Department of Natural Resources, the Nature Preserves Commission, and the Natural History Survey that are all concerned about this and have all been monitoring, taking tissue samples, and documenting injury across the state. Other states across the Midwest and South are experiencing the same thing. This is from a slide of one of our partners, the Nebraska Forest Service shared with us. There were participants in a multi-state program where many states collected leaf samples from symptomatic trees and had them analyzed for residues of herbicides. 78 of the samples that they collected, which is all of their samples, came back with residues of 2,4-D and dicamba. So this is very similar to what Missouri found and other partners in this program. So it is everywhere, and it is a problem that we're all working together to try to address and build awareness on. And now I'm going to pass it along to Emily May from the Xerces Society to talk about what this means for wildlife.
Thanks so much, Kim, for sharing all of that monitoring data. My name's Emily May. I'm a pollinator conservation biologist with the Xerces Society for Invertebrate Conservation, and have been working with these great partners on this issue for the last 4 years or so. So I'm going to talk about what does this mean? What does it mean to see these levels of herbicide across the landscape for wildlife, not just for pollinators, but also for other insects and all of the critical wildlife dependent on them. So herbicide drift on millions of acres of wild plants could have broad ecological consequences. And in most cases, they're not being monitored. So we have folks here in our network that are monitoring, but that's not happening across many millions of these acres. And I think we're most concerned about the critical relationships between native plants and animals that might be being affected by this contamination. Native trees and plants host thousands of species of insects, groups of trees, including ones that Kim showed you, like oaks, as well as willows and birches, poplars, cottonwoods, and maples. Each host over 300 species of moths and butterflies, many of which not only serve as pollinators, but are also critical sources of food for wildlife, including birds, bats, and raccoons. Next slide. When we think about how herbicides might be harming insects and other wildlife, it's important to remember that many of these species and ecosystems are already experiencing multiple stressors. We talk about habitat loss, climate impacts, including things like droughts and floods and fires, competition from invasive species, as well as diseases and pathogens. So many groups of flying insects, including species of butterflies, bumblebees, and beetles, are already experiencing severe population declines. So that's some of the context to keep in mind as we talk about direct and indirect impacts of herbicides on insects. So what are some of the ways in which herbicide use might threaten wildlife? One of the most significant is landscape level loss of food plants and nesting and shelter for pollinators and other insects from broadcast applications. Herbicides can kill or damage nectar producing plants and pollinator host plants, decreasing both the availability of food resources as well as that quality of remaining food plants. And then direct harm from herbicide exposure is also somewhat of a concern. There's some research showing that direct contact with dicamba can be harmful to adult lady beetles, which is an important beneficial insect for controlling soft-bodied insects like aphids. And then feeding on herbicide contaminated plants could also be harmful for some insects, depending on the levels or how the plant is responding. Some caterpillars that fed on dicamba treated plants experienced reduced larval and pupal biomass. I think in general, we know very little about the short-term and the long-term effects of the widespread use of these herbicides across such large acreage of land. Many of these areas are experiencing multiple exposures a year, not just from herbicides, as Kim showed you, but also a complex blend of other pesticides, including insecticides and fungicides. Next slide. I did want to show you one of the more dramatic examples of herbicide impacts on pollinator food plants, which is, of course, milkweeds, the main host plant for larval monarch butterflies. That figure on the left there from USGS shows the massive increase in glyphosate use from the 90s into the 2000s, mostly in corn and soybeans. And as that glyphosate use in herbicide-resistant crops increased, milkweeds decreased across the Midwest. There were monitoring surveys conducted in Iowa from the late 90s into 2010, which found steep declines in milkweeds, about a 30% decline in non-agricultural milkweeds and an 80% decline in agricultural milkweeds. So that's an important part of the migratory range of the monarch on the Eastern Flyway. On the right, that's a figure showing an estimate of monarch egg production in the Midwest across that same time frame. So this herbicide-based weed management meant a massive loss of food resources for monarchs across this important part of their route through the US. And this reduction in food for caterpillars has been linked to declines in monarch butterfly populations over that same time frame. So this is just one story for one species that we're all familiar with, but I imagine that there are similar stories out there that haven't been told. Next slide. So what do we know about herbicide drift? We know that herbicides and their drift can affect the quality, diversity, and quantity of plants available as food and shelter for wildlife. Herbicide drift can reduce the number of flowers that plants produce, they can delay flowering, and they can ultimately reduce seed production, which is important for considering how these plants reproduce in their environment, especially the herbaceous plants. We also know that flowers exposed to dicamba drift are visited less frequently by pollinators. One of the things that you'll sometimes hear from weed scientists and crop consultants and others who work with herbicides is that glyphosate, particular, one of the top herbicide used in the US, is practically inactive once it's in contact with the soil. But there's actually recent research showing that glyphosate residues in the soil can reduce the quality of leaves of plants growing in that soil. So maybe we should be looking closer at what that means for host plants, for example. So I think in general, there's just a lot of knowledge gaps around this. We're concerned about loss of potential food quality for herbivores, pollinators, and the whole food web that depends on them. So long-term, are we going to see shifts in plant communities as some sensitive species start losing out to others? And then what does it mean to see these repeated drift events over time for within growing seasons and for many years in a row? We all know that when we're stressed, we're much more susceptible to disease or illness, and it's much the same for plants. So if a plant is weakened or stressed by other stressors like pests, diseases, flooding, droughts, etc., all of that can have a compounding negative effect on their health and survival. There's important wildlife depending on these plants, relying on the seeds and the fruits, nuts, cones, bark, and flesh of trees and other plants. These plants are providing habitat and shelter. And so if we continue to stress out our populations of wild plants, some might not survive, and what remains might not be able to support the level of diversity of wildlife that we are accustomed to. I did want to include a slide here from our partner at American Bird Conservancy about impacts on birds. So North America is currently experiencing major bird declines. There are 3 billion fewer birds estimated across the North American continent since 1970. And pesticide use is one of the main threats to birds, including herbicides and habitat loss due to herbicide drift. In Europe as well, agricultural intensification is the biggest driver of bird declines. For species like the corn bunting here in the middle, herbicides in Europe made up the 5th highest toxic loads and are potentially responsible for the loss of millions of corn buntings, which is a common species found near farms in Europe every year. And as I mentioned before, drift from dicamba and 2,4-D has been linked to decreased seed production in beneficial plants like coneflowers and other seed-producing herbaceous species. So this can decrease vital food resources for seed-eating birds, particularly as they migrate south, and could lead to generational population declines with loss of food resources. This is really the doom and gloom section of this talk. I'm sorry, guys. I also wanted to talk a little bit about aquatic ecosystems. Most of my time is focused on thinking about terrestrial insects, but many herbicides are water soluble and readily enter water bodies and surface water where they could pose risks to aquatic life. Some herbicides like dicamba and glyphosate have been shown to harm development in some toad species. Amphibians have permeable skin and can allow for rapid exposure and uptake of these types of environmental contaminants. So contamination of water bodies has the potential to affect not only amphibians, but other aquatic invertebrates and fish, and also the animals that rely on aquatic systems for food and water, including birds, mammals, reptiles, etc. So I hope what I'm conveying here is there's a pattern of how widespread contamination can ripple through all of these interconnected pieces of the natural world. So for my last slide, I just want to emphasize this knowledge gap piece. There's significant knowledge gaps, data gaps that remain. How much herbicide is volatilizing into the atmosphere? When EPA, the US Environmental Protection Agency, is doing its risk assessments for pesticides, it's modeling particle drift, as Leica showed the graphic at the beginning, but it's not including vapor drift in its risk assessments. So how much is volatilizing? How much is that impacting plants in the environment? Where and how far are these herbicides traveling, and at what rates are they landing on unintended plants? So one thing I wanted to also mention here on my last slide, I mentioned that insects and other wildlife are experiencing complex blends of different kinds of pesticides across our landscapes. Many of these pesticides are systemic and end up in plants, including in pollen and nectar picked up by pollinators. But herbicides are actually really the only ones of those that have this outward visible symptom of injury. The rest of that contamination is largely invisible. So this is one piece where we are getting a window into how some of these chemicals are moving through the environment. But there's major gaps in our understanding. We're currently bearing witness to quite a bit of resulting contamination from the chemical weed management system in our agriculture. And so it's time for us to try and get a handle on this and really start to deal with the consequences. So I'm going to turn it over now to if you want to go to the next slide, a recorded segment from Rob Fox, a specialty crop producer at Genuine Fox Farm in Bremer County, Iowa, and a great partner on this work. He's also a communications director at Pesticide Action Network.
Hello, my name is Rob Fox. I am communications manager for the Pesticide Action Network, and I'm also a small-scale diversified farmer in Northeast Iowa. We have a 15-acre farm, and our farm is surrounded by large monocrop fields of corn and soybeans. We've been farming since 2004. We grow pretty much every vegetable you can think of from A to Z. In Northeast Iowa, we have a 15-acre farm, and our farm is surrounded by large monocrop fields of corn and soybeans. We've been farming since 2004. We grow pretty much every vegetable you can think of from A to Z, and we have had a CSA up until recently, and now we just do direct sales and donate to the food bank. And we have also raised poultry, including chickens, turkeys, and ducks. We also have a small orchard and a few other things on this farm, but it keeps us busy. And what I'm here to talk to you about today is some of the effects of herbicide drift and pesticide drift in general on our farm. And this may be something that concerns you as well, especially if you are living next to places where pesticide applications are common and frequent. What you see on the screen in front of you right now are actually two examples of a drift incident we did have with herbicide on our farm fairly recently, within the last couple of years. And what you see on the left is cucumbers, and what you see on the right are some peas. If you look closely, you'll notice that there are small round spots, slightly different sizes, of yellow and white on both types of leaves. And if you look closely, you might see there's actually even a blade of grass in there that has a little bit of that spotting on it. This is a classic symptom of herbicide particle drift, probably not a volatilization drift. And in this case, we knew that there was a drift situation coming because the wind was coming our direction. We noticed an individual come up to us with a spray rig for the field that was to the windward side from us. We went out and talked to them. They talked to their boss, and the boss said spray anyway. So of course we were on the alert to look for possible drift. And sure enough, the next day we noticed the damage on these crops. And it's pretty much, this is what it would look like. So here are the things, if you're looking for the possibility of drift, obviously the first key is to notice what's going on around you. First of all, is somebody applying pesticides are in your area? And second of all, what's the weather look like? Which way is the wind coming from? What were the temperatures, etc.? If you're observant of what's going around you, then you will know to look for possible drift situations. The other thing that you can do is you can possibly smell that there have been chemicals applied in your area. And that's a good reason for you to pay attention to what's going on and observe if there have been any problems, any damage that might come as a result of that. You are probably going to notice that you have had a drift incident if there's sudden onset of symptoms, and that onset is widespread, not a small part of a plant or a couple of plants showing possible damage. In this case, we had no damage one day, and then of course there was a sprayer, and the next day we had damage on a wide range of plants over a fairly wide area on our farm. So this is a classic case that was very clearly herbicide drift. So the question is, of course, why is this such a big deal to alternative growers and to people who grow food? The first issue has to do with food safety. The chemicals that are used are not necessarily rated for human consumption. Most of these chemicals, if they are rated for food crops, they're going to have what's known as a setback period in their use labels. In other words, the label that says this is what you can use this product for and how you use it will actually list all of the crops that this is to be used for, and they will have a setback period for things like peas or cucumbers, that if you could use this herbicide around them, then you would want to wait until that setback period is over before you could harvest and eat anything. So for example, this product might have had a setback period of 30 days. If it did, then that would mean that I should not harvest anything from those peas, for example, for 30 days. If you know anything about cucumbers and peas, you probably noticed both of those plants were actually either just about to be producing in the case of the cucumbers, or were already producing in the case of the peas. That means that anything that I've got set on that crop is not safe for human consumption. And as a farm that sells produce for people to eat, because of food safety reasons, I could not harvest and sell any of those products. In fact, I destroyed those crops because there was really no way that they were going to end up being safe. And as a small farm, if I sell people anything that could make them sick, and they do get sick, I would be responsible for what happened to them, not the people who sprayed. It would come down to me. I would be held responsible. Another thing that we need to consider is a small farm that has people working outside all the time, is that we have to think about worker safety, including my own safety as the farmer. And there is usually what is known as a re-entry interval, REI, that is also on these labels, that indicates how long people should stay out, and for that matter, animals should stay out of the area of spray. And if spray drifts to your home, to your farm, you are now in an area that you should not re-enter for the period of time on that use label. In the case of the drift situation that I talked about before, the re-entry period was 48 hours. So technically, we should not have been going out and working or doing anything in the field that showed drift problems for 2 days. And if you're a small farm like ours, you often can't afford to not do work then. So it's a difficult thing, but nonetheless, we are responsible to our workers and our own health to keep ourselves out of spray areas. Some of our crops, of course, are very sensitive crops. So if an herbicide is sprayed and it drifts for whatever reason, those crops can be damaged. And that, of course, is a loss that we have to deal with. And of course, we also have beneficials and pollinators that help us on our farm. Cucumbers, for example, on our farm need to have pollinators. And if we are having trouble with our population because of pesticide drift, then we're going to get less production on our cucumbers. And other crops are very similar in that regard. I mentioned we have poultry on our farm. Some of you might have dogs or cattle or horses or whatever. They're all exposed as well. Remember that re-entry period could apply to any mammal, for example, or to poultry. Sometimes poultry are more susceptible to issues because of various pesticides. In our case, when we've had drift, we've had to move our poultry to a different pasture so that we didn't keep exposing them to the chemicals that have drifted onto our farm. Sometimes you will lose animals in severe cases. Those are all things that we have to think about. And finally, a small farm like ours, we don't have the benefit of crop insurance like the large row croppers do. So these losses are often uncompensated. We have to go through the process of reporting to our state agency and also trying to work with the farmer who owned the field where the spray came from, or if you're talking about maybe some turf spray somewhere else, you have to think about going to the company that made the application and seeing if their insurance will compensate you for your loss. And the process can be difficult, but that's about the only way you can get compensation. And then finally, the workload gets increased. Anytime you have a drift of a pesticide application, there's a whole heck of a lot more you have to do. You have to clean your containers. You have to remove crops that have been contaminated that are no longer safe. It basically becomes a very difficult situation. So here's an example of dicamba drift. We've been talking about dicamba some prior to this. In 2016, dicamba was registered for over-the-top application on soybeans. What that means is they began allowing the spray of dicamba after soybeans had emerged and they were actually up out of the ground. So that means the applications in Iowa are typically in June. And when that happens, the temperatures are a little bit higher. So it's more likely that dicamba is going to volatilize and drift and move to different locations. So one example of damage on our farm from dicamba is our bell peppers. Typically, we would harvest between 750 and 850 pounds of marketable fruit for our bell peppers in the field. And then after 2016, you'll notice that the amount that we were able to harvest from our fields of marketable fruit went down to almost nothing. 30 pounds in 2017, 5 pounds in 2018, and 51 in 2019. At the same time, we moved some of our peppers into what are known as high tunnels. They're plastic covered buildings. And those plants actually did just fine because they were being protected from the dicamba drift. This is a good way for us to illustrate that it wasn't a disease we were perpetuating on our farm that was causing problems. It had to be some other environmental issue, and it comes from the dicamba drift. As a result, we stopped growing peppers outdoors. We could only grow them indoors if we wanted to have them at all on our farm.
So I'm going to turn it over now to Max Sano from Beyond Pesticides to finish this out. And I see that there are a few questions that maybe will be answered in this last part of the presentation. And then if we don't answer them now, we'll get to them afterwards.
Thank you, Emily. I'm the Organic Program Associate at Beyond Pesticides, and I wanted to go through some of the potential steps that you can take if you suspect exposure. Pesticide use can be an emotionally charged subject, and so it is important to be proactive in building constructive relationships with your neighbors ahead of time so you can stay informed on when and what will be sprayed. That being said, if the law in your state says pesticide drift is illegal and there needs to be notification, then that should be taken seriously and reported appropriately. Looking up whether your state or county has a notification ordinance is a good starting point. Aside from that, initiating communications ahead of time, such as before growing season, and asking questions around the use of pesticides, which types of pesticides, is important. Opening conversations ahead of time and in a neighborly way is more constructive in the long term. But in terms of before and during the pesticide exposure, it's important to ensure your pets are indoors or any hanging clothes are brought indoors as a good step to take if you know of that spraying in advance. During the spraying itself, it is wise to keep yourself out of harm's way. As Rob mentioned in his section of the presentation, the effects can last for up to 1 day to up to a week after the application. After spraying, you can continue to fact find on a variety of topics, including the mode of spraying. So if it was from a plane or a truck or drone, any noticeable side effects from wildlife, such as strange behavior in bees and pollinators, as well as documenting the damage, at least in terms of herbicides. It's important to document that before and after damage. So you want to take photographs immediately after the application to show how it was affected before the chemical was sprayed, as well as follow-up shots from the same angles, and trying to take as clearly defined notes as you can is pivotal. And in terms of the vegetation, you want to make sure that you can take samples if you can from the site of application and place those in separate, clean, and tightly sealed plastic bags and put in the freezer until you can share with via a state agency or EPA. The same can be said about pollinators or beehives. So it is to examine any hives immediately. This is more for beekeepers. You can, if you notice a handful of dead bees, put them in a freezer, same process, tightly sealed plastic bags for possible analysis. You want to make sure when you're doing this information gathering that you're keeping all of these components in mind so that you can submit a report to the state agency, to EPA, or submit an ecological pesticide incident report with NPIC if it specifically has to do with herbicide damage. Next slide. So Beyond Pesticides has a range of informational resources on how to contact EPA and state agencies in your region or state, as well as finding a lab to conduct pesticide residue testing, as well as a template for filing an incident report, as well as other additional resources. And if there are any other questions pertaining to documentation or the process in which to keep track of certain elements, feel free to reach out.
Thanks, Max. And let me know in the Q&A if you have any other questions or have trouble seeing the resources we've been trying to share. But just want to conclude with talking about a sort of sustainable vision that we have for a shift from herbicide only to other ecological weed management systems. And a number of our organizations are working together to advocate at a sort of policy level for greater investments in technical assistance to help growers and producers move towards these systems, and public research investments around making our growing system more resilient and more ecologically sound. And also to help with reducing the lag in adoption rates across for these techniques across growers. So with that, we've been talking a lot, and we did want to have some time for questions. I am going to, the next slide has a lot of our, has all of our contact information, and we can leave that up for a while as we start trying to answer some of the questions. And so I'm gonna try to read out questions, and anyone on the panel is welcome to answer. So I believe we had, the first one said, what is the hardest part of monitoring for herbicide drift, and how can people get involved in reporting suspected cases of drift? So I think we answered this in certain ways, but maybe the first part, Kim, you can address that.
Yeah, so I think being able to identify the symptoms, I mean, once you see herbicide injury, it's kind of hard to unsee it. You start to recognize it in places where you wouldn't have thought there would be injury. And so, you know, when we go to a location, we look for the symptoms again in multiple plant types and the forest floor or the ground layer, understory, and tree canopies, and looking at the similar symptoms in multiple places. We have a photo library of symptoms in different species on our website at prairieriverse.org, and you can go there and explore and learn a little bit. In terms of reporting, I highly recommend that people report the injury to their local state regulatory agency. That information gets sent to US EPA, and US EPA really relies on that information for improving the regulations and enforcement.
Thanks, Kim. Okay, we have one other question, and that is, if plants are showing us these chemicals are pervasive in our environment, what does that mean for human health? Is there research underway to address this question?
That's something that perhaps I can start the conversation with, if that's okay.
Sure.
Some of what Beyond Pesticides has done over the years is trying to track the latest scientific literature and analysis around like adverse health impacts for wildlife, for ecosystems, as well as for human health. And so you can go to our website to Gateway on Pesticide Hazards and Safe Pest Management, where you can put in a chemical name or a product name or a certain side effect and be able to see through resources there. But there's a lot of ongoing like research and data in regards to human adverse health impacts, especially when thinking about it from an acute versus ambient exposure. Otherwise, I can defer to anyone else in the panel.
Yeah, I think I specifically focused on environmental impacts. Human health impacts are not my area of expertise, but there certainly are finding plenty of chemical mixtures in drinking water samples as well. But again, not my area of expertise, so didn't want to speak too much to human health impacts. I saw there was another question about what the chemical was that Rob had been drifted onto with, and I think there's actually he's experienced multiple drift events that I think got him fired up about this issue in general. So if you're interested in that, he did give a webinar with Practical Farmers of Iowa, I believe last year. I'll see if I can send it to Leica to share in the chat. But he talks a little bit more about the series of events that he experienced there. I'm not exactly sure what that specific drift event was.
Yeah, I believe in the presentation he mentioned this what they suspected dicamba for that example, the cucumbers and the peas. But yeah, Rob wasn't able to join us live, but his email address is up there too if you would like to reach out directly. I think that is all the questions we got. As we said earlier, we did record this and we'll be happy to share the recording with everyone that was on or registered for the webinar, and we'll include some of the links that we've been attempting to share in the chat. But thank you everyone for your time today and for listening to our presentations, and hope you stay engaged on this issue. Thank you.